Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, this is a pre-recorded session this week as I'm traveling, but if you do have any questions, if you're joining us on Zoom, just make sure you reply to the email that you got, the confirmation email and the reminder email. That'll go right to my email inbox, and then you can just type your question there, and I'll reply to those as I can. If you're watching this on YouTube, just leave a comment underneath the video, and I'll get to those when I can. And then the same thing with Facebook. If you're watching on Facebook, leave a comment under the video, and I will get to those when I can as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last, starting on my 10th year now, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So worked in a dealership, and I guess over time became the default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is going to be next level lab scope. So maybe you use a scope, maybe you don't use a scope. I would definitely encourage you to try and use the scope as much as possible so you can get familiar with testing it, because it can help us out a ton when it comes to tough diagnostic problems like comebacks, intermittent problems, things of that nature. But maybe if you use a scope, maybe you only use it to test voltages, or I just want to test a cam sensor or a crank sensor, one thing at a time, perhaps. So we're going to take you through a few different functions of a scope and a few different scenarios that may help bring you to that next level and test other things on a vehicle more than you might be doing now. So let's start off with ignition system testing. So kind of a couple different rules of schools of thought when it comes to ignition testing, especially nowadays. And you might think, well, coil on plug vehicle, why would I need to test it? You can tell a lot about how a vehicle is running by testing the ignition system, doing a few different tests on the ignition system. Plus, I'm sure you've run into a failed coil or two over the past, however many years we've had coil on plug vehicles. So just because it's coil on plug doesn't mean we don't need to test it. There's definitely necessity out there for it. But we might need something a little more than just our base lab scope. We might need some accessories as well. So for a Snap-on tool anyways, of course, going to focus on Snap-on tools. Many scopes have ignition capability, but for as far as the Snap-on tool is concerned, in order to use any of our ignition probes, you need at a minimum this cable right here, which also comes with the capacitive probe here as well. And what that does is this end goes into the scope. So we have the yellow and the black there, goes into channel 1 and the ground. And then this side is a male RCA adapter. So that'll plug into any of the other accessory ignition items that we have out there. There's also this inductive sync probe, which you can use for channel 1 to tell the tool where channel number 1 is. And that plugs into the fancy little D-sub connector on the scope as well. So that'll work with any of the tools with 4-channel scope. So old school Modus, 4-channel Varus, and then the ZEUS Plus. That'll work with any of those units. And of course, anything with the 4-channel scope will also have the ignition capability built into it as well. You can test ignition on Tritons and Moduses, but it's just a little bit different. It doesn't have the specific ignition testing function. You can kind of get around it with the regular scope. And then as far as the probes, probably the best way to start, especially with coil on plug vehicles, is going to be these flags here. They're actually very reasonably priced if you take a look at those. So it's going to notice how it's got a female and a male end on it, so they can actually be daisy chained together. They're available in singles, doubles, and triples, and that will allow you to put them on the coil on plug on a vehicle. and it will send the signal to the scope, and then we can analyze it. We also have some vehicle specific coil on plug adapters that are available out there as well. It's just they're a little more specialized for certain types of vehicles, so a really nice universal way is with these flags. And then, of course, you may have seen this before. We've had this out for quite some time, and this is the SIA 2000, they call it. So this is a ignition adapter that works. It was designed to work with waste spark vehicles. Back in the day, GM had a ton of them. Ford had a ton of them. Lots of manufacturers went with a waste spark system for a while before they transitioned over to the coil on plug vehicle. So that's what this was designed for. If I had a vehicle with coil on waste spark, which one fires positive, one side fires negative. It actually has a positive side and a negative side on it as well. In later years, as we've gotten closer to modern times where we're at now, because we do still have this available, it actually comes with multiple RCA adapters. So you could use single coil on plug adapters, multiple of them with this tool. If you have it, it still is very viable, very usable accessory. I know a lot of people just have it sitting in the bottom drawer of their workstation. So that is definitely something that's available as well. So once I have all this equipment and I can hook up to the vehicle, what am I going to look at? Well, there's a couple different ways we can view ignition using a scope. First way, and that's going to be pretty much anyone with a scope would be able to see at least single cylinder ignition. In this case, I also almost have two ignition events on there, but single cylinder ignition, we can do that with any of our scopes. And then when it comes to the specialized patterns, the more ignition specific patterns, we're going to have our parade pattern, which will show all the cylinders on the screen at one time. You have to connect to all the cylinders, of course, but it would show all the cylinders on the screen at one time in like a parade, one after the other. And you can actually set up the firing order. We'll talk more about that when we get live on the tool here in a little bit. I can actually walk you through a few of those things. But you're able to see who's the odd man out. See how one's much higher and this one's much lower. So you can see, well, that's the one I want. That's the cylinder I want to investigate. It's going to be the one that's higher or lower. And we can, there's more involved classes that we have on ignition testing. This is kind of here's some more things that we can do. We also have raster, which is going to have all the cylinders kind of stacked on top of each other. So we can see how they're burning each individual cylinder and kind of measure off the other ones and see, is one of them rich, is one of them lean, one of the cylinders doing what it's not supposed to be doing. And then we also have superimposed. That's kind of a carryover from the old Sunscope days, where you can have them all on top of each other. It doesn't really label the cylinder, but it can at least tell you, hey, I do have an issue here, and then maybe flop it over to the raster or the parade at that point. So those are used to compare time, and then these two are used to compare voltage. So I want to compare my firing voltage or my spark line voltage, and then my time. So what are some tests that we can do? Without even accessory probes, we can do a primary voltage test. It's going to connect directly to the ignition coil primary circuit, and we're going to be able to see, what's going on with that. Depending on the vehicle, depending on how the coil is designed, how the coil is set up, the pattern might look, a little more detailed or a little less detailed than doing secondary ignition. So in this case, in this primary voltage, what we're going to see is right here is where the coil starts to charge. And then we see how the primary voltage kind of drops off a little. And then when it actually fires, we see a firing line right there. Not a ton of detail compared to a secondary ignition, but at least we can see that the primary is kind of charging up. And then we can see the jump right there for the spark. If I were to compare that to a secondary, we can see here's where dwell starts. You can see where it drops off. We can see where dwell is here, and then we can see my firing line there, and then my spark line over here. So you really don't see the spark line on the primary, but at least you can see whether or not the coil is firing using this test. If you want to get a little bit more involved, that's where you get in the secondary test. Can also, if we have a low amp probe, we can use primary current. So on the same power feed circuit that we were on before, we hook the low amp probe around it, and then we'll be able to see the current ramp of the current flowing into the coil. So once dwell starts, I'm going to start charging the coil. So the current available is going to increase and increase and increase. In this case, on this vehicle, it is a current limited design, so it goes up to about 12 amps and levels off. And then when it fires, the current leaves the coil, so it should go back down to 0. We can see if we have any problems in the system, depending on how this ramp looks. And also, we've seen some other vehicles where they had actually a negative current when it fires, and that indicates a problem in the coil, the connection to the wire as well. So a couple things we could see there. As we would compare the current ramp to the secondary, we can see how it matches up. So that as the secondary goes into dwell and starts charging, the current flows up until it fires right there. Here's an example of a bad primary current. So this is on a multi-strike coil, so that actually fires multiple times per event. So we can see how the ramp goes up very sharply and then over. That indicates that there's a problem with the windings in the coil, so it's requiring too much current to flow through in order to start the charging. And then it eventually does work, but way too much current inflow in there at the beginning. Should not look like that. Should look like a nice smooth ramp, more like this. So this is on the same vehicle. So we have the bad one right here. You can see how it's almost straight up and down. And then we have a good one where it's going more of a ramp. Now, in this case, it just goes up and down as it fires. So you can see how it fires multiple times. On the second and subsequent firing events, you will have that high current flow on those because it has to overcome what's already in there as it's firing. But the first one is what we want to look at in that case. So that's doing, we did primary voltage, primary current. Now we can also do ignition control signal to make sure that the computer is controlling the ignition the way it's supposed to as well. So if we hook up, once again, a back probe there, nothing fancy we need, then we can go in, and usually that's just going to be a 5-volt square wave. In this case, it is. When the 5 volts turns on, that's the signal for the coil to start dwell. And then when the signal turns off, that's the signal for the coil to fire. So as we can see how that matches up as well. You see we got my 5 volts up as dwell starts, and then when it fires, it comes back down. Now where we can really start to see detail is when we get into secondary voltage. If you have a ignition system with wires, coil wire, plug wires, you can connect directly to the coil or wire with that inductive probe. Or if we have the flag pickups, we can go directly to the coil with the flags and then hook up that way, and we should see something kind of like this. This is on coil on plug, actually on my vehicle. So we can see where dwell starts right here, and then it builds up, and then when it fires, we see a firing event, and then we see the spark event over here until it finally drops off and flattens out. So a standard spark line or firing line or just an ignition pattern, let's just call it that, a standard ignition pattern. Here's what it roughly should look like. So it's gonna be in 3 parts. We're gonna have a dwell section where it's actually charging the coil in there, and you'll get some ups and downs here at the beginning. When it first starts going in, it's kind of rattling around a little bit, so we get a little bit of these ups and downs here. And then it comes up and then it fires. You'll have a firing line. You're going to have a very tall voltage line when it needs to jump that gap on the spark plug and start the path of the spark. Then we have the spark line, which we can analyze and see how is the vehicle running. Is it rich? Is it lean? And we can also see how much turbulence we have. And then depending on the system, if we have a lot of energy left over after the spark occurs, we're going to have these ups and downs here. They call in the intermediate section. This would be the coil ringing out. It's getting rid of any excess voltage and current inside the coil. And then it eventually levels off, and then it starts back with dwell again, goes back over here. So with dwell, we want to see dwell. We want to see a good firing line. We want to see a good spark line. So in this case, this is on a known good vehicle. This is on a vehicle with plug wires. So we see a firing line of about a little over 10,000 volts. And then the spark line comes down and it is relatively flat. We want to see it relatively flat. We want to see a little bit of turbulence up and down in that as well. And then we see this one's pretty efficient. It only has a couple little bumps there after the firing event. Now on this same vehicle, we went and introduced a lean condition on there. So we pinched off the fuel line slowly to starve the vehicle for fuel. as it does, we can see the spark line's pretty normal for a little bit, and then it jumps up at the end. So this jumping up at the end indicates a lean condition. So if you ever look at a secondary ignition pattern and it goes up towards the end or even halfway through in this case, that indicates a lean condition in that cylinder. So once again, we can tell a lot about that cylinder. In this case, this is a different vehicle with coil on plug, but it was a rich condition. This car needed a tune-up. So it was a rich condition. So it actually goes down towards the end because the voltage goes down. The more fuel there is to burn, the richer it is. It takes less voltage to go through that. So we can see that there. And then on this is after a tune-up on the same vehicle. Now you can see it still kind of goes down, but it's flat. The reason it goes down on at a straight angle like that is due to probe placement mainly on that vehicle. So it wasn't quite level even, but if we were able to put the flag in a little bit better spot, we would have seen it was fairly flat. So you just kind of want to see overall, is it straight or does it have a bit of a curve to it? So this indicates rich. This indicates lean going up, rich, normal, flat. Okay, so that's ignition. If you want to see any other information, we actually have a couple classes on this. If you watch back in some of our earlier classes, I do full ignition classes on actually a couple times on that. So that's ignition. Pressure transducers, another thing we can do. Pressure transducers can be used. We do need a few other accessories with that as well. Depending on your tool, we have the split lead adapter, which can actually hook up 2 of the pressure transducers. So you can actually look at 2 things. It also has this specialized D-sub connector. Now, we do realize on the ZEUS Plus that the D-sub is on one side and the colored connectors are on the other side. We do have a revised adapter. It's actually the same part number, but we do have a revised adapter with longer leads now. Not sure if they're quite available yet, but they will be very shortly. I've had a couple people ask me about that with the pressure transducer adapter. With that split lead adapter, we do have ones with longer leads. Not 100% sure if they're quite available yet, but they will be in the near future. And then we have 100 PSI, 500 PSI, and 5,000 PSI per transducers as well. So that is your max pressure that's available. Also on the tools that don't have the D-sub, we do actually on tools with the D-sub, you can use this as well. But this is a it's a battery powered unit. It's called a PSA adapter as well. So on the ZEUS with the top feed there, we can just plug right in. Got channel 1, channel 2, and we got the power adapter there, which goes over here. Or we could also use the PSA adapter as well, and that also has availability for 2 pressure transducers. What can I test once I have this set up? I can test fluid, right? Fuel pressure, transmission pressure, hydraulics, up to 5,000 PSI with a 5,000 PSI adapter. Can also test gas pressure. So a lot of folks will do like an exhaust back pressure test, or we can do a compression test. You can do a cranking compression or a running compression, which seems to be the more popular test that we get asked about a lot lately. So running compression test is a good one to do. As far as fluid testing, we can do, here's an example. We have a fuel injector. On the green line is the voltage for the fuel injector. The blue line is the current flow through the injector. And then this yellow line is fuel pressure. So this is actually a vehicle that had a starting problem, a cranking problem, because it was dropping fuel pressure massively. So it was like a 30 PSI drop when it was cranking. And the reason for that is because we had a really long injector on time at the time. So it was like 250 milliseconds, a quarter of a second. So on this vehicle, it had an issue. And we noticed it because of the wild fuel pressure swing. So it would go from 60 PSI to 30, back up to 60, down to 30. Wide swings, dropping a lot of pressure, was just dumping fuel into this vehicle. And that's why it wouldn't start. So they figured out, they actually traced it back to the 5 reference line. Something was shorting it out. So it drew everything else down, and it thought it was very, very cold out. So it was dumping a lot of fuel in there. Once that was fixed, it went back to normal. And we actually were able to check it out with the pressure as well. But that's just one thing. Adding pressure to your fuel injector test could help if you had some sort of an issue like that, or we didn't have a flow issue or a pressure issue there. Running compression, that's like I said, that's the popular item right now. So this is a good way to tell in a cylinder if I think I have a problem with compression. Do I have a problem, and where is the problem? So really, this is a one cylinder at a time type proposition. What you would do is you would take an adapter for, say, a compression gauge. Take the compression gauge adapter. You want to take the Schrader valve. There's a Schrader valve, and those usually take that out. And then you would adapt your pressure transducer to it, and you can see how it runs. You want to disable the fuel too, so you're not flooding out the cylinder. But you'd be able to see the compression event, and then the downstroke of the piston down here. So we get a little vacuum pocket. Then we have the exhaust, and then we have the intake again, and then we have compression, and then we have the firing stroke again. So you'd be able to see it go up and down. You can see, analyze what's going on in the cylinder. This is an example of a good one. This is an example of a bad one. So this is on a 08 Saab 5.3 liter. And there was no compression on this particular cylinder. So you can see we have like no compression at all. And then the vacuum pocket comes down, and then we have like very little, no exhaust pressure either. Intake, compression, there's like no compression on the cylinder. If you compare it to a cylinder next to it, though, on cylinder 8, cylinder 6 to cylinder 8, you see we have considerably more compression on that cylinder, about 60 psi or so, and then comes down to a good vacuum pocket, exhaust, intake, and then our stroke there. So big difference on the same engine. This cylinder had no compression. This cylinder was good. So you can definitely tell whether or not you have compression by doing that test. So that's a little bit more advanced, right? Here's another one. This vehicle had a clogged cat. So we could see the compression event comes down, comes into the exhaust stroke, and the exhaust stroke had positive pressure actually ramping up in positive pressure. So we don't want to see positive pressure when the exhaust valves are open. So you see positive pressure or growing pressure when the exhaust valves are open. That means the exhaust can't get out. So either the exhaust valves aren't opening or there's a problem in the exhaust. So in this case, it was a clogged cat on this particular vehicle was causing the exhaust stroke pressure to ramp up. And then if we want to get really, really fancy, this is one I took off of my vehicle, and it shows the compression, shows the ignition event, and it shows the fuel event for the injector. So as my compression goes up, almost pretty close to top dead center, we have a little bit before, we have our ignition event here, comes down, and then we go into exhaust phase. You can actually see some of the other cylinders playing with the exhaust pressure there. This is the 4-cylinder vehicle. And then we have the fuel injector fire. Right after the fuel injector fires, my intake valves open, so that you can see the end of the exhaust event, and we have a little bit of crossover in the intake. We can see how the flow actually changes a little bit, because now we have fuel, and now we have the intake coming in. Then we have a little bit of a vacuum pocket here on the intake side. We can see we got a lot more turbulence, and then it goes back to the compression event again. Once all my valves are closed, compression event, ignition fires, down comes the piston. So you can see all 4 strokes of the engine operating, everything, ignition, fuel, air, compression, all working within the vehicle, within the cylinder. Now, I know I said earlier, you want to make sure you disable the fuel, and that is true. I just wanted to do this to see where everything falls on the actual running of the engine, right? So that's just a kind of an interesting example, I thought, of how we can see everything going on by using a pressure probe, ignition. This is just ignition primary, and then the fuel injector all at once. So I just thought that was kind of interesting. Since I'm there, I might as well see what's going on. And then we get to multi-channel correlation. So this might not necessarily be as advanced as pressure, if depending on your opinion, I guess. But in this case, we're looking at a vehicle, and we have the crank sensor is channel 1, so that is the yellow. One of the cam sensors is on number 2, which is the green. Another cam sensor is on number 3, which is the blue. And then channel 4, we have the fuel injector for number 1 cylinder on that as well. So we can tie them together and we can see cam crank correlation, how the cam and the crank are lined up with each other, and see whether or not it matches a known good. So in this case, we actually did have a known good to compare to, and we'll talk about that in a second. But we have a lot going on. Right, so we got a couple cam sensors, crank sensors, fuel injector, lots of things going on. So we might want to separate that out, and actually I can show you how that works in a minute when we go live on the tool. So we actually separated out the channels. So now I got my 4 channels, and it's a lot less confusing, and I can see how everything lines up. So there's my correlation there. I also use this channel 4 as a trigger, kind of lock everything on the screen and make it so it's not moving around a lot. So it actually locks it in place as well. And then if I really wanted to get fancy, we can put the scope on one side and we can put the scanner suite on the other side, and we can compare. So this is my known good pattern right here. And we can see how I got that, I got that, I got that, I got that. And I got my how everything kind of lines up there on my cam sensor and my crank sensor. So that is my multi-channel correlation there. So we can do that if we have multiple channels on a vehicle. We saw that a little bit earlier when I went into the pressure transducer, right? We had pressure transducer, we had ignition, and we had fuel injector all at once on the same screen. Earlier than that, we had the fuel injector voltage, we had the fuel injector current, and we had the fuel injector fuel pressure on the same screen as well. So there's a lot of different tests that you could do by using multiple channels and seeing how they correlate using the same time base. That's another key when you're using a scope, to keep the time base the same, so you can see how everybody correlates together as far as when things are happening. They should be on the same time base, locked in the same time, in order to be able to see that. So let's go live on the tool, and we will talk about a couple things. So first off, if you have a SnapOn tool, which I'm assuming the majority of you probably do if you're in this class, I know not everybody does, and that's fine, but if you have a SnapOn tool, and that SnapOn tool has a scope, then it's going to have this guided component test module. Inside the guided component test module, there is a wealth of information without even IDing a car. We have these classes available. So if we go into classes, a couple specific places I'd like to direct you to on your tool. So if we go into power user tests, it is going to give you, well, for one thing, dual channel tests. We just talked about that, having cam and crank relationship, or throttle position sensors, pre and post oxygen sensors, CAN bus. Lots of things do 2 channels. We could also do 4 channels on a few things, but cam and crank relationship, that's one that's a preset. We also have secondary ignition on the 4-channel tool. So we can do coil near plug, coil on plug, conventional. Distributor list is going to bring you through a couple tests on that. Pressure transducer tests as well. So we can do a line pressure, EGR temp sensor versus vacuum, fuel pressure and fuel pump, fuel pressure test, exhaust back pressure test. Lots of different tests in there. And then if I go even further into how to, in here, there is, if I can find it, there's a running compression test, which talks about running compression waveforms and how to walk through that and how to interpret that, just by looking at the different speeds and so on. So there's a lot of information in here when it comes to that. Let's see. So that's just in the classes. Now let's go into the scope itself. If we go into scope multimeter. So we do have the digital meter, the graphing meter. One thing in graphing meter too, it's not a scope really, but it's a graphing meter, which is similar, just on a longer time base. But in here, there is one thing that we can graph in that's ohms. So few people asked me about this. Some time ago, we took it out for a little while, and I'm not sure why. But it is very useful for things like transmission shift solenoids, things of that nature, being able to graph the resistance of it over time. So as the transmission temperature comes up, or so to say, We could graph that over time. We could actually graph 4 channels if we have a 4-channel tool. So that's helpful. Then also on the 4-channel tools like the ZEUS and the ZEUS and the old school Modus, we have the ignition scope in. So in the ignition scope, we have the different patterns we talked about earlier. So things like parade. So in this case, we have our cylinders in parade for, say, an 8 cylinder engine. So say if I wanted to do this, we can walk you through it. Like I said, in some of the other classes, we have ignition. But let's go into set up my ignition. And then we would set it up what kind of ignition it has. So standard, wave, spark, direct, or other. How many cylinders on the vehicle, what the firing order is on the vehicle, and what I'm triggering my number 1 cylinder off. A coil or is it a plug? And that'll allow us to see what is going on in each cylinder. And then it also does an automatic RPM calculation based on when it sees a firing. So that's all good stuff to know. Like I said, we delve into this deeper in the ignition class. But we'd be able to see each cylinder firing. Now, this is just a repetitive sample pattern. So you're not really going to see any difference, but is one higher, is one lower? What's my firing line look like per cylinder? And we can see the firing order on the bottom. So 1, 8, 4, 3, 6, 5, 7, 2 is my firing order that I set up. So that's handy. Here's your parade. Also have single cylinder, which will do a single cylinder on the screen at a time, but we also told the tool our firing order. So we can go through here and we can go cycle through each cylinder as well, and it'll show it. And then we also have that raster pattern I talked about, which stacks them on top of each other. And then we can see time-wise, it's also going to go by firing order starting at the top. You can see time-wise, how do they react to each other as well. And then talked about also the pressure transducers, right? So if I was going to go into pressure transducers, I went too far, I can go into lab scope. And then I can either just go right off my pressure transducer itself. So I recommend, in my experience, I seem to get the best looking pattern with the most detail by using the 500 PSI pressure transducer and the split lead adapter. Seems to give me the best pattern. So if you can go into 500 PSI pressure, you do need to calibrate the probe first. I don't have it hooked up right now. So it's going to fail my calibration, but you can tell it what probe it has, what scale you want to use. Same type of thing you would do with any other scope test, which, like I said, this is a next level scope test. So we're not going to walk through all the basics on how to set up scale and sweep and trigger and all that. There's other courses on that. I can actually link them down in the bottom if you in the YouTube description. I think that's probably the best thing to do. So look out for that after the video is done. So that's for our pressure transducers. Once I do have a signature loaded, though, we could actually go in and take a look at some of those as well. So let me actually flip over to my laptop here. And we do have this tool called, where'd it go? There it is, Shopstream Connect. And what Shopstream Connect does for us, this is for free, and you can get it downloaded off our website. Just look up SnapOn Shopstream Connect. And what this does for us is when we record patterns, you can actually go in here and take a look at that pattern. So here's that example I showed you earlier where I had, let's see if I can get 2 on the screen here. There we go. So this is the example I had earlier that had the pressure, fuel injector, and the ignition event all on one screen there, right? So you can see how we can kind of go through. We could take a look and measure with cursors and see how long things take. We can see, where my vacuum pocket lies, where my exhaust lies, and so on and so forth. So you can actually use Shopstream Connect to do that. Another thing that someone had asked me is there is a program called pressure. What's it called? I have it on here. Pressure waveform overlays. So this is a free program you can install on a Windows laptop, desktop, that sort of thing. Only available through the Windows Store. That's why it can't be installed on a ZEUS or a ZEUS Plus, because it does not have the Windows Store. available on it, just so you know. I've gotten asked that a few times. But what you do with this is you would open up a file. So for example, I'll open up this file right here. It opens up JPEG, bitmaps, that sort of thing. So if I wanted to analyze a file from my ZEUS, for example, I would use the S button to take a screen capture that saves it as a JPEG file. It will upload it to the SnapOn cloud, so I could then download it on my laptop and I could open it up this way. Once I've done so, we can set up some rulers. So there's an example for a compression ruler. And we just take this and we put number 1 right here. So that's the top of the event. And then we take 720 over here, and that is the top of the next event. And then we can see here's the expansion phase. Here's the exhaust phase. Here's the intake phase. And here's the compression phase. And then it goes back down as well. So we can see how it's reacting and where everything is and what phase we're actually looking at of the cylinder's compression events. It's also other things. This one's for a different type of graphic, be cylinder ID to see which cylinder is what. This one allows us to see valve overlap as well. So if it knows where the exhaust valve is, it knows where the intake is, and we can see overlap. And if a manufacturer has a set overlap that they want, you can actually go in there and click on it and change it as well. You can move it back and forth. So a couple different ways you can do that. So the easiest way, like I said, to do that, pause the recording, take a screenshot with the S button. It'll upload to the SnapOn cloud. You can download it from the cloud, and then you can open it on your PC, laptop, desktop, what have you, where you have this program installed. Like I said, that is a free program called Pressure Waveform Overlays you can do. And then you could download it that way. All right, so we talked ignition, we talked pressure. The last thing we'll talk about is going to be screen and screen. So if I want to analyze something in between, front door, back door, that sort of thing, I'm just going to pull up my demo Tahoe here. All right, so let's say I want to do a functional test on my evap solenoid, right? So purge solenoid, it's in a percentage. So I have a purge solenoid valve that I want to run up and down, and then I also want to see on the screen with my scope whether or not the duty cycle matches. So I can go in here and I can do it by percent duty. First thing we want to do is load into the scanner function. Now we're in the scanner function. So next thing I need to do is go into guided component test. This only works using guided component test. It doesn't have a separate button in scope multimeter. So we can go into guided component tests, and it'll carry the vehicle over. I need to go into my engine. And in this case, I'll go to my evap system because that's what I'm testing. And my purge solenoid. We can do a duty cycle test, a resistance test, or a signature test. In this case, we want to do that duty cycle test because that's what we're testing. In order to do screen and screen and make it work right for you, I mean, you can make it work regardless, but to make it make sense, I guess, we have to have the same thing going on in the scope that we have in the scanner. So if we're doing duty cycle, we need to do duty cycle. We're looking at voltages on my PIDs. I need to do a voltage test on my scope, right? So we have two different ways. So we'll go into duty cycle test because that's what we're testing on the other side. Yellow goes to purge control. Black goes to no good ground. We'll go into view meter. This is too high, so I'm going to drop it down. This is a little knob, so it's not exactly exact, but it's close enough, right? We can change our duty cycle. Let's say that's 10%. Once I've done so, we can go back up to the meter. That makes it full screen. Meter one more time, turns it into a window. Then I can move it around and do what I need. Once it's in a window, go to home, go to scanner. My test is still running. And come down here to the bottom, pull up my taskbar, pull up my scope viewer. I can then grab it, move it over to the right. You see how it kind of turns gray there on the right-hand side. Let go, moves it over there. Windows 10 asks me what window to move. That one over there. So I got my 10% here. Then we could, I want to go up to 20, go up to 20, up to 30, should react. 40 should react. All right, and then we should be able to see 70% there. All right, so you should be able to see it react. Now, mind you, I'm doing this by hand, not on a real live vehicle, so it's not 100%. But if, let's say I was sending a 70% duty and I was seeing like a 50% duty instead of 70. So the module's commanding it to be 70, it's only at 50. That means there's a problem somewhere. It's not returning a 70% like it's supposed to, it's returning a 50%. So that would say maybe there's a problem in the wiring somewhere. Maybe there's a problem with the solenoid itself, too much resistance, something like that. So being able to see that functional test on one side, results on the other side, because this purge solenoid valve could be it's usually in the front, but if it's a vent solenoid, it could be in the back. So just being able to have that functionality to functional test on one side and scope it on the other side and see the result. So that's kind of your more advanced stuff there as well. I can see what's going in the front, what's coming out the back, and see it all on the same screen at the same time. All right, so that is my time for this evening. Let's talk about what we're going to talk about next week. Next week is going to be information systems navigation. So as I said before, these classes, these first 5 classes of the year this year were taken from you all. So we had towards the end of the year, a little bit before Christmas last year, we had, what would you like to see? What do you want to learn about? So this is really driven by you all, the viewers, and what we want to see. So we wanted to see more advanced scope stuff. So that's what we talked about tonight. Before that, it was secure vehicle gateways. Next week's going to be information systems navigation. I had a couple folks say, hey, how do I go in and interpret a wiring diagram? How do I get this information? How do I navigate quickly to find this information? So we're going to walk through, a couple different examples next week of walking through different information system information. All right, TSBs, wiring diagrams, that sort of thing. So hopefully you can join me again, same time, same place, 6 and 9 Eastern. If you want to join on Zoom, you go to snapon.com/OT and sign up there to register. Then 6 p.m. Eastern goes live to our YouTube channel. So it's youtube.com/SnapOn Diagnostics. If you are watching on YouTube, please make sure you're subscribed, ring the bell, give a thumbs up, all that good stuff. Helps the algorithm out a lot, helps us out a lot. Be able to do more of these classes and give you more information. The 9 p.m. Eastern class also goes to my Facebook page. So it's facebook.com/SnapOnJason. If you want to go give me a follow over there, you can do that as well. If you want to see any of the past prior classes we've done in this series, will be anything from ADOS through forced induction, starting and charging systems, component testing we've done. So we're up to class number 56 in this series, and that'll be available on YouTube shortly as well. Once again, youtube.com/SnapOn Diagnostics, and you can go to a playlist with all the live training on it. That brings us up to Q&A. So with since it's being a pre-recorded course this week, like I said, if you're on Zoom, reply to the email, the confirmation email from Zoom, and it'll go right to my inbox. If you're watching on YouTube, just leave a comment and I'll get to those when I can. Same thing with Facebook, just leave a comment under the video and I'll get to those when I can as well. I'd also like to announce that we have a new trainer. Al McCaskey has retired after 33 years with SnapOn. So he was a wonderful resource. I had a lot of great times training with him. But now we have another gentleman, Keith Ray, who has equally as much knowledge, if not more, than Al had as well. So he came over to us from Sun back in the day. So he's been with us for over 30 years as well. So he will be taking over the scan tool training. So Wednesday is still going to be ZEUS. And then Thursday, what we've done is we've combined Apollo and Triton together into one class, because the scanner functions on both of those tools are going to pretty much function the same way. So we combine those two into a one class. So if you have an Apollo and you go through the first hour and you don't really want to learn anything about the scope or the other features of the Triton, then you can always hop off at the break there. So it's like a 5-minute break in between. So he's going to walk through. Let's set up your Wi-Fi. Let's set up your SnapOn Cloud account. Let's make sure you're all set with Secure Vehicle Gateway on your tool as well. Where do I need to enter all that information? Then he's going to walk through code to completion, from the start to finish with Fast Track Intelligent Diagnostics. How does it help me as a technician diagnose cars faster, easier, better? And then after a 5-minute break in between, he's going to go take another hour and go through scope, meter, guided component test, all those different functions on the tool as well. So if you want to sign up and check that out, snapon.com/OT is where you can go to sign up for that. And I'd like to say thank you very much. Appreciate you taking a little bit of time out of your busy schedule to spend a little bit of time with me. Hopefully we learned a few more little tips and tricks to take our scope use to the next level, test some ignition, some pressure, maybe do some side-by-side screen things if that's what we have. And hopefully it'll just bring you a little bit further along in your diagnostics career. So with that, enjoy the rest of your week. Enjoy your weekend. Hopefully we'll see you next week for information systems. Have a nice weekend. Have a good night. Take care.